Let's have example 4. Did you get bored yet? You are not allowed to get bored with that. Okay. Example 4 is an example, is a famous one, like 172.16.0.0, and this time they informed me, Sajjad, use /16. A much smaller subnet mask means a much bigger domain. A much bigger domain. Okay, so 16 means 16-bit. 1, 2, 3, 4, 8, 9, 10, 11, 12, 16. Done. Done. That's it. So 17, 18, 19, 20, 4, 8, and 32. That's it. Between you and me, done. Pardon me for the narrow line. All right. So network portion, host portion, 2 shadows completely fixed, 2 shadows completely flexible. All right, something nice. Reminds me of 24, where there were no mixing, while 26 and 23 had some mixing within an octet. All right, let's continue. The rules. Go back to the rules. All right, 32-bit minus 16-bit in the subnet mask equals 16. Oh, big number. 2 to the power of 16 using a calculator will result in 65,536, which is the increment value. When the increment value is bigger than or equals 256, we divide on 256 once, twice, thrice, I think it's in English, until we reach a number in the calculator that is smaller than 256. Why? Because other than that, we will need a chalk, we will need a board, super long board, and we will continue counting 65,536 IP addresses starting from 172.16.0.0 until we reach the broadcast domain. So it's either the chalk and board, or let's use the method. Again, the method says, all right, the method says this. The increment value over 256, resulting in 65,536 over, let me have the result here, over 256 in the calculator is 256. 65,536 over 256 is 256 in the calculator. Use it and see. All right? Because I've done that like 100 times before when I was teaching and showing them the calculator. All right? So when I have it in that way, this is a little bit, let's say, too much. This is a little bit too much. Okay. If it was a little bit too much, if you say so, then again divide it. 256 over 256. This time it's 1, which is a result that is smaller than 256. Okay, so the number of divide today equals 2 times. I divided twice, and the result was 1. This is the difference between them. This is just a column between them. I divided twice, and the result was 1. What should I do with this? What should I do with this? The number of divisions equals the number of filled octets. Completely filled, completely filled. How do you fill an octet so that you can't add more IP addresses to it? By representing 255. How many times? Twice. Done. Is it? Done. So once here, twice there. Okay, this is number 1. What about the 1 that was left? Well, if I use the last example method, it says that deduct 1 from it. What will be left is 0. The 0 here, the 1 As a coincidence, is this 255, neglected. The 0 here is what you should add, or what you should do. Actually, let me make it in a simpler way. What's left in the calculator, just deduct 1 from it. What is left? 0. 0 is the addition that you should add a different color will be better. 0 is the addition that you should add to the octet that we have just reached to, which makes sense. 0. Why? Because it's 16 and its shadow is fixed. So 16 plus 0 is 16. But sometimes it might not be /16. It might be /15. Try it as a homework. In a /15, this one will be 0. There is a flexibility. There will be a value in here. The value will be added to this number. So 172.16.00/15 will result in 255 here and here, yes, but there will be a different number in here. It will not be 16. It will be a different one. 172 because the shadow is fixed. And going back to the original rule, 172.16.00 is the network ID. 172.16.01 is the very first usable IP address. 172.16.255.254 is the last usable IP address. Network ID, broadcast ID, valid range. Little bit better? Yes, more complicated, but if you build, let's say, your basic skills in a good manner, in a professional manner, then this will be super simple for you. This will be really simple for you. Take a break, and I'm continuing right now example 5 before I close the deal with VLSM. Example 5. The biggest subnet mask, the smallest subnet mask, the biggest network in the world is 0.0.0/8. /8 is the biggest. The biggest. This will be represented as 1, 2, 3, 4, 5, 6, 7, 8, I'm sorry, 9, 10, 11, 12, 13, 14, 15, 16, 24, 32. If you remember, you remember. It will be the network portion, the host portion, all the way. If we went back to the basic rules again, then they should look like this. 32 minus 8 equals 24. This leads us to 2 to the power of 24. Using a calculator, this will result in 16,777,216, also known as the increment value. So far, routine, 100% routine. 10.0.0.0 is the network ID. From the increment value, we need to understand how to reach the broadcast ID. Now, before we finish the subject and the video and the part of this course, which is the VLSM part, the increment value is bigger than or equals 256, which leads to divide on 256. Now, in the computer, dividing 16,777,216 on 256 results in 65,536, which is still bigger than 256. Again, on 256, in the calculator results in 256. Is still equals or bigger than 256. For the third time, on or over 256 results in 1. The number of dividing that we did today, the number of divides were 1, 2, 3. What's left is 1, deduct from it 1, which is 0, the effect of the octet. What should that mean? You divide it 3 times. 3 octets will suffocate, will be filled completely with all the mathematical possibilities. 3 octets. 255, 255, 255. Done. 0 added to the 10, which is already fixed. 10. Believe me, and don't take this in a non-serious way. If you have really done a really good work and practice the first 4 examples, this is just a review for you, and not a single subnet mask in the world can scare you, can ever be something to consider investing or spending more time. Done. Couple of minutes. How much did we take here? 3 minutes, let's say, for this example. It should be that way. It should always be that way. So this is the network ID, the broadcast ID, the first ever useful IP address, the last ever usable IP address. Within them, there are 16,777,2014 usable IP address. And this is how I would like to lock and finish the VLSM topic. What's coming later depends 100% on the VLSM. So be certain and careful that you will study VLSM so well before proceeding. Thank you very much.